video is for the Newton's First Law Lab. The objective for the video is to identify the law that says that objects change their motion only when an unbalanced force acts on it. In this lab, you discover that the force of friction between the coin and the card changes the motion of the coin. I'm going to begin simply by resting my quarter on top of my card, which I'm placing on top of a jar. You notice that the quarter isn't moving. That's because the forces that are acting upon it are balanced. There is a downward force of gravity that is balanced by an upward normal force supplied by the card. And since the forces are balanced, there's no motion. We can describe this lack of motion as the coin's inertia. Newton's first law says an object at rest tends to stay at rest. Now, I'm going to move over to this side of the counter and once again, make sure that my coin is over top of the opening of the jar. And I'm going to flick the card. Let's see what happens to the quarter. Oops, I missed. I'll try again. Got it. Notice that the coin fell straight down into the jar. Why is that? Well, I applied an unbalanced force to the card, but the coin's inertia kept the coin relatively in the same spot, the spot over the opening of the jar. So once the card was gone, the coin fell down into the jar. The second part of the lab asks you to reset up with the card on top of the jar and the coin on top of the card. But this time, move the card slowly. When I move the card slowly, the coin moves with the card. Why? It turns out that the static friction, the force of friction between the bottom of the coin and the top of the card is so great that I'm not overcoming it. The coin slides along with the card because of that force of friction. Newton's first law also states that an object in motion will continue in a straight line at a constant speed unless acted upon by an unbalanced force. I'm going to slide my quarter across my countertop, and clearly you see that this quarter just didn't keep on going forever in a straight line at a constant speed. Why not? Well, that's because the force of friction between the countertop and the coin prevented the coin from just traveling off in a straight line. But if I could magically transport myself and the coin into outer space, where I am in a situation where there's very little gravity acting upon me, if I were able to just throw the quarter would continue on in a straight line at a constant speed. Newton once said, "If I have seen far, it is because I have stood on the shoulders of giants." The giant Newton was referring to was, of course, Galileo. And it was Galileo who had the insight that once you let go of the quarter, no additional force is necessary to keep the quarter just moving in a straight line at a constant speed. Galileo even had that inkling of an idea about what inertia is.